Good day, I'm Maile Madziba. Welcome back to our channel. Today we continue with our CIR 113 module. We continue with our semester test 1, the 2018 version. And today we're looking at question 2, continuing from the previous video where we did question 1. It says that you are given the task to determine the density of an unknown powder. Two students in your group each suggested a method to use. The one student suggested using helium He gas to measure the volume in between the powder particles, whereas the other student suggested using ethanol C2H6O. A 250 ml beaker filled with the unknown powder weighs 0.368 kilograms. The beaker weighs 0.12 kilograms. To test these methods, you fill the beaker containing the powder with ethanol. The total system now weighs 0.476 kilograms. Now there's also data here with regard to helium and ethanol and benzene. So question 2.1 says, what is the bulk density and the density of the unknown powder? So bulk density, let me just write down the equation of bulk density here. You can just say bulk density. Let me be specific. Bulk density of the unknown powder is equals to the mass of the unknown powder, the mass of the unknown powder all over the total volume. In this case, it's going to be the beaker. So now, which means that we do have the total volume. Let me just write the total volume here. Let me write the total volume. We do have the total volume, which is 250 ml bigger. That is the container that is actually containing the unknown powder. So now, what we need is the mass of the unknown powder. However, the information we're given, they say that the 250 ml bigger weighs 0.368 kilograms, right? Alongside the unknown powder with it. So, and the bigger weighs 0.12 kilograms, which means the volume of the mass rather of the unknown powder is actually 0.368 kilograms minus the volume of the bigger, which is 0.12 kilograms. So I can just say the mass of the unknown powder, the mass of the unknown powder is equals to 0.368 kilograms minus 0.368 kilograms minus the mass of the bigger, which is 0.12 kilograms. And if you use your calculator, that is gonna give you 0.248 kilograms. Let me just move this a little bit higher now. So we now know the mass of the unknown powder, and we also know the total volume because it has been given to us. So with that said, we can say, but therefore the bulk density of the unknown powder is equals to the mass of the unknown powder, which is 0.248 kilograms all over the total volume of the bigger, which is 0.25 kilograms. This is because 250 milliliters is actually 0.25 liters, not kilograms. This is because 250 milliliters is actually 0.25 liters. Let me just write it properly, 0.25 liters, right? And if you use your calculator, that's going to give you 0.992 kilograms per liter. This then is the bulk density of the unknown powder. Then we come to the density of the unknown powder. So let me just write down the equation of the density of the unknown powder. So the density of the unknown powder, is equals to the mass of the unknown is equal to the mass of the unknown powder all over the volume of the unknown powder. This is basically the mass of the unknown powder and the volume that the unknown powder is occupied inside the beaker. So the mass of the unknown powder we already know because it doesn't change, it's still the same, is 0.248 kilograms. Now we need to know or calculate the volume of the unknown powder. So there's an approach we're going to need to use for us to eventually be able to get the volume of the unknown powder and then use it to calculate the density of the unknown powder. And the easiest way or the more simpler way to actually calculate that is to actually calculate the volume that the beaker, rather the ethanol occupies in the beaker. Let me just make a simple illustration here. This is actually, let's say this is the beaker, right? I hope it's visible. This is actually the beaker, and for illustration purposes, let me just say this is actually the cycle you see. It's actually the particles of the unknown powder, right? So the particles of the unknown powder have occupied a particular volume, and the remainder of the volume is actually, before you add the ethanol, it's actually something that you know that it's actually void. It's actually, I can say it's empty. So you have the powder particles occupying a particular space, and everywhere else there's no powder particle. It's actually some void, some empty space. And now later we are told that, let me just bring back this. Later we are told that to test this method, you fill the beaker containing the powder with ethanol, which means that these empty spaces now are filled by the ethanol, and the beaker is now full, right? So there isn't an empty space now. Is the unknown powder particles, and then you have also the ethanol now that has actually occupied the remainder of the space. So we need the volume of the unknown powder. So basically the approach we can use is that if we can get we already know the total volume. So if you can get the volume that the ethanol has occupied, we can simply then take the total volume, which is 250 milliliters, and minus the volume of ethanol, and then that will give us the answer, or rather the answer would be the volume that the unknown particles has occupied. So the question is, can we be able to calculate the volume of the volume of ethanol? And what do we need to calculate the volume of ethanol? Let's check the information that we have. On ethanol, we have the density here. So which means if we can have the mass, then we can get the volume. And if we can get that volume, then we can actually use that volume of ethanol to calculate the volume of the unknown powder, right? So that is actually the approach we're gonna use. So the first thing we're gonna do, we're gonna need to calculate the mass of ethanol. And remember, we have more information. They are telling us that to test this method, you fill the beaker containing the powder with ethanol, C2H6. Now the total system now weighs 0.476 kilograms. So the system was weighing 0.368 kilograms, right? After they added the unknown powder inside the beaker. But now after they added the ethanol, the system then weighs 0.476 kilograms. That then tells us that we can just say the mass of ethanol, so the mass of ethanol is actually 0.476 kilograms, right? Which is the total system after adding ethanol, minus 0.368 kilograms, which is the total system before they added the ethanol. So then if you use your calculator, the difference would be 0.108 kilograms. So then we have calculated the mass of the ethanol. So, but what do we want? We want the density, rather the volume of the ethanol. So if we have the mass of the ethanol and we have been given the density of the ethanol, then it shouldn't be difficult. Then we can be able to calculate the volume of the ethanol. So we can just say volume of ethanol is equals to the mass of ethanol all over the density of ethanol, right? And then is equals to the mass we know is 0.108 kilograms all over the density we are told is 789 kilograms per meter cubed, is 789 kilograms per meter cubed. And if you use your calculator, it's gonna give you 0.000013689 meters cubed, and this is equals to 0.13689 liters. So now we have the volume of ethanol. Remember, we have the mass of ethanol that is in the beaker. That is actually, we calculated it from being told that after they added the ethanol, the volume now weighs 0.467 kilograms. And if we know the mass in here, we can use the density given to calculate the volume. So then this volume is actually the volume that ethanol is occupied in the beaker. And based on our information that was already established already, we know that that volume is actually the total volume of the beaker minus the volume of that the particles of the unknown powder has actually occupied. So, which means if we have the volume of ethanol, then we can easily calculate the volume of the unknown powder. So we can just say, therefore, the volume of unknown powder is equals to the volume of the beaker, or let me say the total volume excuse my handwriting, guys. The volume of the unknown powder is equal to the total volume of the beaker minus the volume of ethanol, right? Is equals to, we know the total volume of the beaker is 0.25 liters, that is 250 milliliters, minus the volume of ethanol we just calculated to be 0.13689 liters. And if you use your calculator, it's gonna give you 0.11311 liters. So now at this point we have calculated the volume of the unknown powder. And let's go back to the question. Remember the question, they say now we want the density of the unknown powder. This is it here. We dealt with the bulk density, and now we are looking at the density of the unknown powder, and we know it's actually the mass over the volume. So if we have the mass of the unknown powder that we already established in the beginning, and now we have calculated the volume of the unknown powder, then we can easily calculate the density of the unknown powder. And with that said, we can just say density, let me get a clean page. I have a clean page here. So we can just say the density of unknown powder is equals to the mass of the unknown powder. You already know that it's 0.248 kilograms, so that density is 0.248 kilograms all over the volume of the unknown powder we just calculated it to be, let me just verify, 0.11311 liters. So it's 0.11311 liters, and if you use your calculator, that is gonna give you 2.193 kilograms per liter. That is going to give you 2.193 kilograms per liter. So that is actually the density of the unknown powder. Now going to question 2.2, it says if the gas method was used, how many grams of He or helium would be required? Let's just visit the question again. Let's just revisit the question again. Remember, we are told that they filled the beaker that contained the unknown powder was filled with ethanol, right? And then the volume, and then we heard about the total system weighing that. So they want to know that instead of filling the beaker with ethanol, and they now want to fill it with helium instead. So the question is, how many grams of helium would be required? So this is not so difficult. Another important thing we need to get here is that we need to first calculate. They actually want, how do I put that? Like they want the mass of, they want to know that if they, instead of filling the ethanol in the beaker, with unknown powder, they then fill it with, or they opt to fill it with helium. What is the mass of helium that would be required to actually fill the beaker, right? They want that mass in grams. That is basically what the question is saying. So how do we then answer that? First of all, we need to understand a simple thing. We have already established important information about the beaker. We have already calculated the total volume that was actually the total volume that, not the total volume, rather the volume that was remaining after they put in the powders or the unknown powder particles, which means we know already the total. This because we know the total volume of ethanol that was put in there. So if we remove all the ethanol in the beaker and leave the beaker only with the unknown powder, we already know how much volume of helium we will need to use to replace the ethanol. And what is that volume? So let's say the volume of, they need the grams, the mass, but we're going to start with the volume. The volume of He required is equals to the volume of ethanol, right? The volume of ethanol in the beaker. Right? This is because we are replacing the ethanol with the volume. The ethanol with the He and the helium, isn't it? And that volume we have calculated to be, let me just verify, that volume is 0.13689 liters. So we already know the volume that of helium. Let me just write here helium, in case I need to use the pages elsewhere so somebody can see that it's helium. So the volume of helium that is required is actually the volume of ethanol that is in the beaker, right? So if we remove all the ethanol, the volume that is left after removing the ethanol, it's actually the volume that is required. It's actually the volume of the helium that is required to fill the beaker, and that volume we've already calculated to be 0.13689 liters, right? So now, if we have the volume, the volume that is required, and we can then check our data and see what more information we have. If we check our data, we realize that we have the Sg of helium. We can simply calculate our density. So we know that we can just say the density of helium is equals to 0.151 kilograms per liter. Excuse my handwriting. The density of He is 0.151 kilograms per liter, right? So if that is the case, then we can actually use the equation of density to calculate, and you can actually use the equation of density to calculate the mass using the volume and the density, because we know that the density of helium is equal to the mass of helium all over the volume of helium, which means that the mass of helium is equal to the density times the volume. And we know the density is 0.151 kilograms per liter, multiplied by the volume we know is 0.13689 liters. So if you use your calculator, that is gonna give you 0.02067 kilograms. They say they want it in grams, so you can just simply multiply that by 1,000. So that gives you 20.67 grams of He. So this is basically the mass. This is actually the mass in grams of helium that is required to actually use the same method they use ethanol.